Today we're going to be looking at the uncertainty principle formula in physics. So, Werner Heisenberg was a German theoretical physicist as well as a key pioneer of quantum mechanics, and one of his theories is called the uncertainty principle. This theory states that one cannot at the same time know the exact position and the exact speed of an object. This principle exists because everything in the universe behaves like a particle as well as a wave at the same time. A particle exists on a single place at any instance of time, while waves, on the other hand, cannot be assigned a single position because they can be on loads of different places at the same time. An object's wavelength is related to the object's momentum. For example, a bullet is an object that has a lot of momentum and thus has a very short wavelength. A large object also has a smaller wavelength. But for smaller things like atoms and electrons, these can have measurable wavelengths due to their smaller size and speed. For these objects, we can either find out the position or the momentum, but know both at the same time. In other words, if we have a pure wave, we can find its wavelength and momentum, but not its position, and if we have a particle, we can determine its position, but it does not have a wavelength, so we do not know its momentum. In order to find the wavelength, momentum, and position of a particle, we need to combine the properties of both a wave and a particle. If a graph that has waves but only in specific small areas, we can accomplish this. This can be done by combining a number of different wavelengths, thus giving our object some possibility of having different momenta. This is called wave superposition. When two waves are added together, it can be noted that there are places where the there are places where the peaks can combine and make a bigger wave, and other places where the peaks of one wave can line up with the lowest points of another wave. By adding more waves, we can make the wave regions narrower and create a wave packet where there is a clear wavelength in a small region. This packet will have both particle position and wave, including wavelength and momentum properties. The new object is now a quantum object with both the properties of a wave and a particle. When we combine two different waves, what we end up with is a combination of both waves that ends up being much smaller. If we keep doing this, we will eventually end up with a small wave packet where we can both identify the properties of a particle as well as a wave. Even though we now have the quantum object, we lost certainty about the position and momentum of the object. The position is not restricted to an exact single plane, because there's a possibility of the object being anywhere in that specific wave packet that we established. This is why the uncertainty principle stands.